once we saw that particles could be viewed as waves, and this is mathematically predicting their probable locations, then these mathematical equations could be used to predict where an electron is likely to be. And so this is where we got rid of the idea that we have a ring and the electron is on it, or even a set distance from the nucleus, and we got more of a electron cloud type thing where this is distance from the nucleus in picometers. And we can see that for this electron, it's most likely to be 50 picometers from the nucleus, but you can see it could be at any point in time a lot further out or closer. So from that, these equations, we found that there are what we call orbitals, where that are regions in space where the electron has a high probability of being. There are different types of orbitals, and we use these letters to represent the different types. So the types are different shapes. And so like an s orbital is maybe like you would imagine an orbital being. But a p has two lobes. This is one orbital, it just has two lobes. D orbitals have four lobes, at least most of them do, kind of a clover leaf pattern. And the shapes get more complicated after that. Whenever you have p orbitals, you'll have them in sets of three. You'll have, this is one orbital with two lobes, left to right, front to back, and top to bottom. We're going to be doing electron configurations, which means you're going to tell where the electrons are in all of these low orbitals. So we could say the distribution of electrons in the orbitals. Okay, so we need to know which orbitals are in the different energy levels, and luckily there's a pattern. The circles represent an orbital. Each circle is one orbital. And remember how I said that p orbitals come in sets of three, the left to right, top to bottom, front to back? Okay, so that's why every time I write p, I have three orbitals by it. And then we have our pattern that first energy level has just S, second has S and P, third has S, P, and D, and so on. You gain orbital types, and there actually are more, but we won't need them when we draw we do our ground state electron configurations. And like I said, for the P's always come in sets of three. The S's, when you have S orbitals, there's always only one. Whenever you have d orbitals, they come in sets of five, and so on, 7 for the F's, and those are all that you will need, but there's that consistent pattern. Okay, we need to make sure we understand the language, what we're talking about when we say the sublevel name. For example, if I want to refer to those orbitals, I would call them the 2p orbitals, or I might call the whole set the 2p sublevel. Okay. Similarly, if I want to talk about those, I would call those the 5d orbitals. And I might say something like this, which gets confusing. There are 5, 1, 2, 3, 4, 5d orbitals. So you got to really watch the language and understand that this is a description of a sublevel or a group of orbitals.